for drought, early warning, and monitoring. My name, as maybe some of you know, is Margarita Stralaga, and I'm the director of IFAD's Environment, Climate, Gender, and Social Inclusion Division. And Earth observation and geographical information systems are not, of course, we know, the magic bullet that will solve all our problems. But definitely they can really help us a lot to have more informed and evidence-based decisions in our operations. So the topic of today's webinar is highly relevant to our work, especially for colleagues working in the area of environment and climate. As we know, 1/5 of natural disaster damages can be assigned to drought. This is the main cause of global natural disaster losses in the agriculture sector, resulting in $29 billion of a total of $96 billion losses between 2005 and 2015, with obviously the huge impacts on the most vulnerable people in the rural areas we work with. Drought impacts, of course, produce a really bad reduction or high reduction of agricultural productivity, increase food insecurity, and lower the living standards of the rural dwellers. It also can cause social unrest and loss of lives. So today we are very lucky to have two very good speakers from UN SPIDER that will talk to us about how to monitor this hazard using remote sensing. UN SPIDER stands for a United Nations platform for space-based information for disaster management and emergency response, and it's probably the easiest UN acronym to remember. Well, some of us don't like spiders very much, so then it's even easier to remember that there is a UN group working on something as important as disaster management and emergency response. The speakers will also give us a demonstration of the UN SPIDER Knowledge Portal, a one-stop shop for data, information, and knowledge related to the use of space-based technologies in disaster management. So I would like now to introduce Juan Carlos and Radu, who will be talking to us today. Juan Carlos Villagrande León is the head of UN SPIDER in Bonn, in the Bonn office, and he is an experimental physicist. Between 1997 and 2004, he designed and implemented 15 community-operated early warning systems for floods and alert systems in case of volcanic activity in the Central American countries. And since 2011, he is the head of the UN SPIDER program in Bonn in Germany. He oversees knowledge management efforts and advocates the use of space technologies in disaster risk management and early warning systems. And Radu Botes, he's an associate information and outreach officer at UN SPIDER, also in Bonn, and he focuses on information management and communications at UN SPIDER, which includes managing UN SPIDER Knowledge Portal to help users from the disaster management community discover space-based data and GIS tools that are very relevant to all of them. So this event is organized by our division, by the Environment, Climate, Gender, and Social Division of IFAD, and is supported by the GEO group of IFAD, IFAD's Community of Practice for Geospatial Applications. So any of you who wish to join the GEO group, it's a very interesting discussion platform, please send your request to geo@ifad.org, and then you will be part of the emailing list of the GEO group. So without further ado, I will hand over to our speakers, thanking all of you for joining us. Over to you, Oliver.
Well, thank you for the opening remarks, Margarita. So this webinar maybe is familiar to you because we advertised it and attempted to have it in April this year, and we got Zoom bombed. I think was one of the first meetings in IFAD to get Zoom bombed. So today we've got extra harsh security measures today and just advertised it internally, and we have a waiting room. I would also like to thank Alessandra for managing this. So I hope this webinar will be interesting, and I would like to hand over to Juan Carlos, who will explain us what UN Spider is. Over to you, Juan Carlos.
Thank you very much. Good afternoon, everybody. Ms. Astralaga, thank you very much for this opportunity to present UN Spider and what we do. UN Spider, you can see its mission there. We were established by the General Assembly of the United Nations in 2006 to promote the use of space-based information in activities to be conducted in all phases of the disaster management cycle. We belong to the United Nations Office for Outer Space Affairs. Its director, Ms. Simonetta Di Pipo, heads UN Spider, as well as two sections, the Committee Policy and Legal Affairs section. This section is the secretariat to the UN Committee on the Peaceful Uses of Outer Space, that facilitates negotiations among member states on this topic. And since more than 45 years ago, the United Nations established the program on space applications and the space applications section as a way to promote the use of space technologies. And of course, there's an interesting parallel effort to facilitate eventually synergies among these global navigation satellite systems. There's a intergovernmental coordination group on Global Navigation Satellite Systems, ICG. UN Spider, as you can see on the left, was established, and it has two offices in Bonn and in Beijing. We basically have the coordination at the United Nations office at Vienna, where the Office for Outer Space Affairs is based. And in the Bonn office, we basically focus on knowledge management and look at technical advisory support. We benefit from the support of 24 regional support offices. Most of these are space agencies, like in Argentina, Mexico, Algeria, Nigeria, Indonesia, Pakistan, Iran. Some of these are environmental institutions like RCMRD in Africa, the International Center for Mountain Development in Nepal. Some of them are disaster management institutions like the Asian Disaster Reduction Center in Japan, the Asian Disaster Preparedness Center in Thailand, the Ministry of Emergency Management in Russia. Some of them are universities. We have a strong support from the University of Bonn and from the Federal University of Santa Maria in Brazil. We have partners in other universities in Europe and in the University of the West Indies. And together we basically work to support developing countries in these regions of Asia, Africa, Latin America, and the Caribbean to take advantage of the opportunities that are made available by the space community. Our work basically focuses on these four areas. We provide technical advisory support to developing countries. We carry out capacity building efforts, particularly with the support of our regional support office as well. We conduct knowledge management efforts. We work with partners to advance technologies and step-by-step procedures and applications of the use of space technologies in disaster risk reduction, preparedness, response, and recovery. And of course, we foster cooperation as part of the efforts of the UN. Looking a little bit more into our technical advisory support to the countries, we start every support to any country with a technical advisory mission. It's basically a fact-finding mission. It's conducted with several experts from regional support offices and centers of excellence. It helps us understand better what are the existing capacities to access and use space-based information, what are the challenges faced by developing countries. We take a look at policies that looking into the use of geospatial information and space-based information. In some countries, disaster management agencies have already some policies to use geographic information, but not yet space-based information. We look into issues like data sharing among government agencies, and we come up with recommendations. But as I say, these type of missions help us understand the degree of development or capacity of different government agencies. Usually we find that the ministries of environment are very powerful when it comes to using Earth observation technologies. In some countries, the ministries of agriculture are very powerful. In others, it's other ministries. So we basically then follow up with technical advisory support through institutional strengthening missions, capacity building or training activities, and so on. We've already done missions to more than 30 countries. You can see there missions conducted either to Africa, to Asia, Asia Pacific Islands, Latin America, and the Caribbean. These are usually 1 week long missions, and then we follow up with those. Part of our mandate is to facilitate the discovery and access to space-based information. And of course, we try to facilitate the discovery of websites that host either satellite imagery or products developed by the space community. We raise awareness about those opportunities. We generate content in terms of news about what the space community is developing, what's new in the space community, but also what the disaster management community is doing. And of course, we provide background information on space technologies and on how the disaster management community is approaching this type of efforts. You can see we provide examples and step-by-step procedures on how to process satellite imagery to generate particular products. We'll show you some of those in a little bit. And when it comes to emergency support, our mandate is more to link national disaster management agencies with those mechanisms that have been established by the space community for emergency support. There are 3 or 4 of these. The biggest one, the most powerful one, is the International Charter Space and Major Disasters. It is established by the 18 most powerful space agencies of the world there. They are able to mobilize their own satellites to facilitate the generation of maps on the use of the most up-to-date satellite imagery of areas affected by disasters. A couple of years ago, as part of the Copernicus effort, the European Commission established the Copernicus Management Service that provides mapping support in case of disasters around the world as well. We're very happy that they also have a risk reduction effort. They have a risk and recovery mapping service, very interesting. In Asia, there's a parallel mechanism called Sentinel Asia, operated by the Japanese Space Agency, the Indian Space Agency, and other government agencies. And the US operates some of additional mechanisms called surveyors that can provide assistance. Looking a little bit into droughts, of course, we're aware of meteorological, agricultural, and hydrological droughts. And of course, the space community has developed procedures to process satellite imagery to track precipitation, temperature, evapotranspiration, soil moisture, and vegetation, seeing what happens to the vegetation. If you look at satellite imagery and particularly the reflection of sunlight, you can see that the reflection of the vegetation in green vegetation is stronger when it comes to the infrared, but it's weaker in the visible, in the red part of the spectrum. So one type of indicators usually looks at this ratio of the reflectance of the red and the infrared. And this is because when the vegetation starts becoming dry, that the reflection of the red part of the spectrum increases. So you can tell apart vegetation that's healthy, meaning green, from vegetation that is not so healthy, that it's turning out to be yellowish or to brown. And the space community has developed several indicators. Some of them, like the normalized differential vegetation index, give you an idea of what's happening to the vegetation at a particular time. And because the space community has archived a lot of this imagery, you can also compare how severe a current drought is in comparison to previous droughts. Using the MODIS sensor, there's already 20 years of archived imagery on products that you can use every 16 days. And that helps you track what's happening to the vegetation since the year 2000, basically February of the year 2000. So if there's a drought in a particular region of the world right now, you could compare, let's say, what's happening to the vegetation now in September of this year with respect to the previous Septembers all the way to the year 2000, and see if the current drought in September of the year is very severe in comparison to the last 20 years, or it's not as severe. I think that one of those events that we look at for comparisons are El Nino events. You may remember strong El Nino events in 1982-83, in 1997-98, and the most recent one in 2014 to 2016. So it's a good comparison in some countries to assess how El Nino impacted the vegetation in those countries where El Nino triggers droughts with respect to droughts either this year or the previous years. Some of the indices that compare this 20-year trend, one of them is the Vegetation Condition Index. Imagine you take all of the images for just September. So you have 20 images for September's. So in one of those, in 1 year, it's going to be the driest with the minimum reflection, and the other one is going to be the greenest with the maximum. So you can have an idea as to how severe a drought is this year in comparison to that maximum or the minimum. You can do that either with the normalized differential vegetation index that looks at the red and the infrared bands, or you could do it also with the enhanced vegetation index that looks at the red, the infrared, and the blue band. The incorporation of the blue band helps deal with the pollution of aerosols in the atmosphere. Another index that has been developed by the space community that's similar to the standard precipitation index used by the meteorological community is the standard vegetation index. Here you don't compare what's happening to the vegetation right now with the extremes, the driest or the greenest, but you compare with respect to the average view of the vegetation over the last 20 years. How far away you are from that average, either towards the green or towards the dry. So you can see there the equations, and one way to normalize the standard vegetation index is to look at the standard deviation and put it in the units of standard deviation. Here's a couple of examples for Namibia on how the vegetation condition index would look like and how the standard vegetation looks like for different years. So you could see that in the year 2019, things were very severe in Namibia. But of course, these sort of maps at the top look either very green or very red. On the lower part, it's the same maps, but with the standard vegetation index. What you see there more as clear is with the average value of the vegetation. So those regions that are really more red means they're really far away from the average value of the vegetation over the 20 years. Those pixels that are very green mean they're really greener than the average value of the vegetation for the 20 years. Of course, it's up to ministries of agriculture to figure out which one they think will work best for them, for help them understanding how to address droughts. But these are two options that we are promoting. Here's an example for northern Nigeria. And these maps can be developed every 16 days. So if you see on the left margin, you see 1, 17, 33, 49, 65, 81, and it goes all the way down to 353. So you can have 23 views every year on how the vegetation is evolving with respect to these droughts. And we give you a comparison of different years between 2009 and 2017. So you can really see here, for example, that the year 2017 and 2011 and 2015 were fairly dry, whereas 2012 and 2010 were nice. They were very green. So we basically generate these maps for developing countries so that they take note of this type of products, and then we train them to generate the additional maps every 16 days and encourage them to make use of this information, and we of course tell them the sort of things that they need to be in the lookout for. Of course, they need to know ideally which crops are placed in different areas, or whether you have irrigated or non-irrigated crops, to be able to interpret more precisely this type of results. Here's a view at the strengths and the weaknesses. For MODIS data that we just described, it's freely available data. Products are available every 16 days. So if you start doing the maps from February or March of the year 2000, up to this day, it's more than 460 maps, 470 maps. It's global coverage. You can do the observations all year long. And as I mentioned earlier, it's interesting and it's useful in those countries where El Niño triggers drought to compare with the 2014, 2015, 2016 drought maps there. And you can also process this type of products using Google Earth Engine. Of course, optical imagery has a problem with cloud cover. If it's really cloudy, then you can't really see what's happening to the vegetation. So we've developed algorithms to try to remove those pixels which have cloud cover. The resolution for this MODIS satellite imagery is 250 meters. So in our view, it's good for the national level, but it's not so good at the level of a particular parcel. But you can start comparing as of March of the year 2000. The meteorological people have their standard precipitation index spanning almost 40 years now. They start from the early 1980s all the way to now, so they can do 40 years, whereas with this imagery, one can only do 20. FAO has developed a product, the Agricultural Stress Index System, and they can do also about 40 years, but with a pixel size of 1 kilometer. This system developed by FAO a couple of years ago using the Vegetation Condition Index and the Temperature Condition Index. They're both extracted from satellite imagery. And as I mentioned, one thing that they do is that they were able to combine imagery from two different satellites. Satellites that were operational in the 80s and 90s, and satellites that have been operational since the year 2000. Of course, they trade off in the pixel size, but they're able to have almost 40 years of archive to compare. So here's what I'm trying to say. ASIS can give you that comparison between the years 1983 to the year 2020, whereas what we're proposing with MODIS imagery only would start in the year 2020. The drawbacks, of course, for ASIS is the pixel size compared to MODIS. But of course, at the end of the day, I think both of them are useful if you want to really start looking into more details. One of the things that we ask ministers of agriculture and in general, those institutions dealing with disaster management, is to start really putting all of this information into a decision support system. You would take, of course, the meteorological information provided by the national met departments in terms of what's happening right now with precipitation, temperature, soil moisture. You would have the archived information that they have, their standard precipitation index, and they, of course, generate weather outlooks. So that would be part of what goes into that decision support system. From the space community side, of course, you have the MODIS products like the ones we described. If you want to go into higher resolution, you can then see really what's happening to the vegetation with the Sentinel satellites or with Landsat. more and more we'll start seeing satellites that are being able to give you soil moisture. These are satellites that normally try to look and be able to differentiate water from non-water, and they're able to pick up soil moisture. And that, I think, will be a good complementary part to look into droughts. Because, of course, before we see the vegetation turning brown, we see the soil becoming drier and drier. An equally relevant part is to complement all of these with the vulnerability of rural communities, of the crops, the differential vulnerability of crops. Not all crops are as vulnerable as others. Also, the vulnerability of livestock. As you can imagine, cattle is more vulnerable to droughts than goats. And you have to look at the water requirements and, of course, how governments have dealt with historic droughts. So if you put all of this information together in a view of urine, you're able to visualize it, then decision makers can start really deciding more specifically how to approach the impacts of droughts in different regions of the country, according to the type of crops that are exposed, or whether it's livestock that is exposed, and according to the type of social and economic conditions in those particular areas affected by droughts. I think this would be an interesting product to develop, and we're trying to see how to work along the lines of coming up with something like this. And we did have a project to address drought early warning efforts in Central America, but one of the challenges we discover is that unlike floods, where the Met Department really has a strong mandate, in the case of drought, there's no clear mandate. You can see the meteorological departments, you can see the ministers of agriculture, you can see the ministries of environment, you can see in some countries the food and security commissions, all of them sort of saying they have their own early warning efforts for droughts, but where our vision is they should all come together and work together. So this is some of the challenges that we see. The other challenge that we see is that as soon as the rainy season starts, they forget about the drought until it starts happening again the next cycle. So we have to be able to keep on addressing the challenges of drought and go beyond the rainy season with this effort, so that countries are better prepared to face the impacts of drought. And that preparedness has to be done all year long, not when the drought is beginning to take place. Here I would like to pass on the word to Radu. He can give you a lot more information on the data and the tools for drought monitoring. Radu, please.
Yes, thank you, Juan Carlos. So briefly to show and to mention a couple of resources. As Juan Carlos was saying, we're working with different stakeholders, civil protection, but also a wide range of ministries and other agencies on basically getting them on board, getting them to use this type of space-based information from different satellites. Indeed, the Landsat satellites, MODIS data, and more and more the satellites from the European Copernicus program. And one place where we try to basically put all of this together, make it easy to find data sources that could be relevant for certain use cases, make it easy to find software, GIS software, that could be used in such use cases, is the UN Spider Knowledge Portal. So the Knowledge Portal, and you have the link displayed here, is indeed information hub where we will write about recent developments in the news section, but we will also upload and create content that is showing how to use the data. And these are the so-called recommended practices. So you see here a screenshot, and I invite you to discover the wide range of material on the portal. You see here one screenshot of the recommended practice on drought monitoring. These are really step-by-step procedures, tutorials that will be available in different programming languages and different software packages. So someone who's more comfortable with Python will discover that this can be done in Python, whilst maybe someone else prefers R or another programming language. So we really try also on that side to develop different versions that then also correspond to the needs of the target audience, and that can be implemented into the workflows they have, into the systems they have. And that's something we do on a regular basis together with our regional support offices. And we published this on the UN Spider knowledge portal recently. We have indeed looked more at cloud-based solutions. Google Earth Engine, which was mentioned by Juan Carlos, is one of those. The advantage being that before you download gigabytes of data to your computer, you could actually try this out in the cloud process and see a bit what's going on, and then you can go from there. So we're doing more and more on that side because we do see that there's a strong increase in web-based GIS solutions, some of which are not yet fully connected. So I think that's one of the challenges we're also trying to address is how can we bring all of this together? How can we get different platforms to speak to each other? Can we link them? Can we use free and open source software to do that? That's another point that we're quite pushing is indeed the use of free and open source software that makes it maybe easier to get started. We also point to other tools which you find in different databases in the system. So there's a tab that says links and resources, and in that section of the knowledge portal, you can, for instance, search for data sources. You can take drought as the hazard that you're interested in, another hazard, and you can basically then filter from several hundreds of sources. You can select the file type if you're interested in a specific file type. So it's really the idea of doing knowledge management and helping to cut a bit through the noise, because if you start with a search on a search engine for specific data sets, it's going to be difficult. So we're trying to really see what is the space community putting out, what products, what raw data is there, how can you access it? So we will look at it, and how could someone in the disaster management space use it? And then really to provide step-by-step procedures on which we then also do trainings in the countries during our missions. And maybe one final point, we also try to curate lists of external capacity building offers. So, I mean, MOOCs, webinars, we've seen a lot of those, not only recently, but also over the past couple of years really coming up. There are a couple of interesting platforms that allow to build capacity. So that's something we're trying to put together so that people that are interested in leveraging the benefits of space technologies have a starting point from which to venture out and then to implement, hopefully, all these tools in their operational work. Thank you. I think that was the last slide from our presentation. And yeah, I guess we're moving now to Q&A.
Thank you so much, Juan Carlos, and thank you so much, Rado, for this very informative presentation. I'm so happy that we didn't get Zoom bombed. You can see I'm still overcoming my trauma from the last time. And yes, everything went well. So now it's time for questions. Please, you can either raise your hand using the blue hand icon and the Zoom, or you can also write your question in the chat. So we still have some time left for questions and answers. So I see that the audience is still a bit shy.
Maybe we could ask the audience.
Oh, just wait, questions are coming in. So we've got one from Sami and one from Lapo. Lapo, over to you. And then afterwards, Sami.
Thank you very much. Can you hear me?
Yes.
Yes.
Good afternoon.
Good afternoon, everybody. So I'm Lapo Sermonti from the SECAP, the Social Environment and Climate Assessment Procedures. And we are currently reviewing our guiding question for screening the climate risk. For each questions, ideally, there are some risk related, and for sure we're gonna have a question relating to the risk of drought. So ideally, since we need to provide guidances and recommendation and requirements, of course, on how to address such risk, ideally, I was wondering whether, in your opinion, we could include in the guidance notes a link to the UN spider. I mean, if there is a specific risk of drought in a region, ideally refer directly to the link of the UN spider platform that we've just showed us. And if you think that our team could be capable of independently use your platform and address such risk. Over.
Thank you for the question, Lapo. Before I hand over back to Juan Carlos, maybe let's just collect 2 more questions and then we'll go to the answers, yeah? So Sami, your question, please.
Oh, thank you, Oliver. I'm Sami from PMI division, which is Production, Markets and Institutional division in IFAD, and I'm working on water and rural infrastructure issues. So first of all, I want to thank very much Juan, Carlos, and Radu for the clear presentation. And I'm glad also to see the main outputs and the useful tools of the UN Spider being available for free, actually, for many countries also to be explored. I just want to have a couple of questions to both of you, especially about the linkage between such a good tool, exploring the NDVI and the MODIS imagery, with deciding whether we are facing really a drought situation or not. I am making this question because it is a really good indicator that something is happening when you compare many images for different periods, and especially for the same month, for example, between one year and another. But according to your opinion, is this can be linked only to drought? Because many other factors actually can interfere there with socioeconomic mainly factors. And I take the example of any irrigation area, irrigation projects, for example, that in 1 year they decide to crop X crops, the second year they decide to change, and then the response of the signal is changing. And sometimes the poor farmer is not able even to crop for 3 or 4 years consecutive. So he keep the soil bare. I mean, there is no cultivation there. So sometimes we are dealing also with this consideration. So, and to which extent we really make this linkage, because it is really serious, between what we are interpreting from the imagery and deciding or concluding that we are facing a drought situation. This is the first question. The second one, it is really interesting to deal with MODIS imagery, and I had some experience with that at national scale. Do you have maybe in future perspective any program to enhance the resolution? We are talking about 250 meters, right? So if that one can be enhanced, or let's say more detailed, we can deal not only with regional or national scale, but also at large projects, I mean a large irrigation project scale, and it will be really, really very useful. So thank you very much.
Thank you, Sami, for the questions. Juan Carlos, I still have one more person who wants to ask a question. Do you want to answer the 2 first questions now, or can we take a third one?
If you want, we take a third one.
Okay, then let's take a third one. Guyo, over to you. What's your question?
Okay, thank you very much, John Carlos, and for your presentation. I have one question. I think the large scale Earth observation, MODIS or NDVI, work in different ecosystem differently. I think because I have a lot of experience in dryland areas where basically the green pasture does not necessarily translate to quality pasture. Sometimes brown pasture is more of quality than the green pasture. So most people use NDVI and other tools that you presented because of the cost aspect, because it gives a large scale observation. But then you lose the quality, which basically you can only get from the perspective of the land user in terms of whether the greenness that is observed through the earth observation translates into the quality in terms of pasture, in terms of the forage. How do you handle that? Because I think in some of the methodologies in the market, integration is the thing where you bring within the methodology the perspective of the land users to improve the quality of what you get. I don't know whether you already considered this within that, or this is still evolving area that should be considered. Thank you.
Thank you, Guyo. Guyo is one of our experts on pastoralism. So over to you, Juan Carlos and Radu.
Thank you very much for the questions. I hope I got them right. If I understand, the first question is, of course, having a link to the knowledge portal to present information and risks. We have general information in the portal on risks from the point of view of the disaster management community. So we provide this information more for the space community so they understand a little bit how the disaster management community makes use of these terms. And we do have these step-by-step procedures to process satellite imagery to generate information like the one we showed. And Radu also mentioned the data application of the month and general information. So of course, we could work with you to develop more relevant content that could be placed in the portal or in the IFAD website. I think it would be better if we understand better how you want to approach the definition of risk so that we can generate content that is better for your stakeholders. I hope this is something that we could work together. That would be my answer to that question. On the second question, of course, when we look at these comparative maps over 20 years, I fully agree there would be a difference between areas without irrigation, areas which are irrigated. There is, of course, some challenge if there's a change in crops over the years, or if, as you mentioned, some farmers may not carry out agricultural activity over a period of couple of years, and that introduces a little bit of, let's say, noise into the calculations. When we go to countries, we definitely tell countries that one of the starting points has to be knowing the types of crops and land use, and knowing if it's irrigated or not, because they need to be able to interpret more properly what comes out. I think this is critical for ministries of agriculture to be aware of the types of crops, changes in crops, and irrigated or not irrigated areas. And then they're able to use more precisely this type of information. The third question on the resolution. Of course, we are looking into ways to bring in the higher resolution of the Sentinel imagery, but the Sentinel satellites have higher resolution, but they don't have the 20-year archive. So in our view, I think the best thing for us is to try to build in this archived over 20 years, and then take advantage of the Sentinel imagery in higher resolution, let's say this year, to see what's really happening. That's how we envision the use of both, let's say, the 20-year archive and the higher resolution of the Sentinels. So we cannot ask the Sentinel yet to give us a 20-year comparison, but we can see the high resolution. So we just have to be able to come up with procedures that combine the two of these. And that's a work in progress. On the question by Mr. Guyo, of course, I understand fully what you're commenting on the loss of quality. Again, I think that there we need to know exactly what type of crops or land coverage there. And you correctly pointed out, MODIS is free, and we encourage the use of open software solutions. So there's a trade-off in terms of quality and access to data. If a Ministry of Agriculture has enough resources, they may be able to do a much better local assessment. Even with drones, for example, they may start using drones for that. But if you still want to do this 20-year comparison to look at how severe the drought might be, of course, if you want to compare with previous El Niños, then you have to rely on archived imagery. One of the things that I did pick up a little bit, this happened to us early in the year in Honduras. Honduras was, the National Disaster Management Agency was telling us that Honduras was facing a very severe drought at the beginning of the year. But we were not able to see that in comparison to the last 20 years. We said, we don't really think this is a very bad year compared to that. Same thing with Mozambique a couple of weeks ago. We said, we cannot really say that this year there's a severe drought, but we can show you the maps for the last 20 years. We can show you the maps for particular years like 2005 and 2008. And you can see that those years were probably worse. You can see that the vegetation is drier in those other years than in this year. So at times we look into trying to answer, is this really a very severe drought, or is it more a perception of a severe drought? I think the question that we cannot really answer is one about soil degradation and the impacts of soil degradation on crops. That may not necessarily be related to droughts, but just if you've been farming a soil for over 20 years and it's being degraded, then we may mistakenly think that it's a more something related to droughts and vegetation as opposed to soil degradation. So I hope I was able to answer your questions. Rado, would you have any other comments?
So I would just want to add a couple of points. The first question regarding risk. So of course, we do have different products and content on the portal, and you're more than welcome to make use of that and to link to it, especially the recommended practices, the step-by-step, which indeed allows to develop information product. What we also try to do, because we're conscious of the fact that there are more and more services that will provide cloud-based solutions and actually derived products such as a risk map, we also keep an eye on those and add them to different databases. In terms of droughts, for instance, there are several portals. One is developed by indeed by the Copernicus program of the European Commission. So that's the Global Drought Observatory. There's also a European version. And then there's also the Flood and Drought portal that colleagues from UNCCD are also developing as part of the drought toolbox. And these are platforms that will give us some indication of the risk. Of course, it is important to have a look at the methodology to understand indeed how that risk index comes about. You know, what are the factors? What is it that they are bringing in? Resolution is another question. Sometimes it's not very high resolution, so that varies, of course, as well. So there are some of these platforms, and you might be able to extract some sort of risk indicator from that. Again, it's worthwhile to read the documentation carefully to understand a bit how that comes about. The other questions on indeed on the NDVI and also on MODIS resolution. One thing to highlight, and that's something we're also trying to do, is, and it was mentioned in one of the questions, the integration. So the issue of integration, how do you bring together not only different sources of space-based information? That's to a certain extent a technical question. There are certain standards, there are web map services, web map feature services, web map services that have time dimensions and so on. So there's on the technical level in the community, there are different developments and different standards by now that allow you to plug one source into the other and maybe bring all of them together in a GIS like QGIS, if that's something that you're interested. But I think it's also the question of traditional knowledge, of local knowledge. How do we design systems that indeed facilitate integrating that type of knowledge, combining it with information that might be obtained from space in this case? How do we bring in situ information and space-based information together? So yes, on the technical side, but also indeed conceptually speaking, and also simply in terms of building products that make that easy. And we're looking to a certain extent at that question when we work with countries. We're trying to understand what data is available, what insights are available. As Juan Carlos was saying, we're asking, of course, about how land is used. When the question then becomes, how do we capture this in a GIS, for instance, and how do we combine it then with products that we're aware of from other sources? And that, to a certain extent, still a development, a recent development, as in we see more and more web-based services. We see so-called analysis-ready data, which has been processed. It's not the raw data that you get from the satellite. It's it's already a bit processed. And how do we then build the systems that capture all of that, whilst not forgetting the local and again the traditional knowledge? So I think that's because then indeed you understand whether green is good or not, and you have the knowledge at the end of the process. All right.
No, thank you, Juan Carlos and Eduardo, for the responses. I can maybe refer to Margarita's opening remarks where she said remote sensing is not the magical bullet that will solve all problems. It's a tool for us to use in order to support our decision making. And of course, we have to work with local expertise in the local ministries and so on. I've got a question from Juma. She says, how do we encourage countries who lack expertise in technologies to interpret and utilize spatial information?
The way we do it, of course, there's different ways, but the way we do it, as I say, is we do try to engage the national agencies and take them step by step on the type of data sources that are available and the type of products that could be derived, and ask the questions about, for example, please have a look and see if you feel that you would be doing better if you use the vegetation condition index as opposed to the standard vegetation index, because that helps them start this discussion. But as I said, some of our challenges rely more on what happens when the rainy season starts. It seems like the effort on drought stops, and it may not necessarily be complete, but for them it sort of stops. So we have to be able to keep the momentum going. It's basically a challenge. The other thing that we do is say that we develop open software solutions. We look for solutions that are built on open software with open satellite imagery, so that there is no complications in the future, a year from now, about the government agency not having enough funding to acquire licenses. To give you an idea about the cost of software licensing, if you have a software license for a software that can process satellite imagery, ERDAS or NV, a yearly license is about $10,000. Two licenses would be the equivalent of a vehicle. So it's hard for the minister to sort of say, I want to buy licenses every year versus something more tangible that we can make use of for several years. So we also have to think about this type of cost-benefit relation from their point of view. We just cannot come up with and say, you need this type of costly software, and if you don't have it, you will not be able to take advantage of any of the opportunities. Because what we see is more even the space community making these solutions available in open software. The European Space Agency, for example, developed open software to process radar satellite imagery that's really great to see which areas have been impacted by floods, and which areas are not yet impacted by floods. But we are aware that in developing countries, we have to come up with solutions that are usually very low cost or no cost at all. I think the biggest challenge we find at times is in some government agencies, the access to large bandwidth in the internet. Government agencies may buy let's say one access to the internet and divide it into 50 staff members. So the GIS person there has to compete with 49 people for a little bit of chunk of internet access, and at times that is limiting how much they can download. And this is where we start looking, as Radu was commenting, on Google Earth Engine and this type of solutions where they could do more in the cloud, and they don't have to download hundreds of megabytes of satellite imagery or gigabytes of satellite imagery.
Maybe just to add one element which we see from our work is if you co-develop products, if it's basically what we're not necessarily, coming with developed products, with finished product, we try to take the user on. So the whole, if you want, philosophy of, agile and so on that you see with iterations, with being very close to the end user and so on. I think we've seen success stories where indeed disaster management agencies quickly set up GIS units, started doing maps, started even do some maps under such under activations of mechanisms that were presented, and that's something where you co-develop. You don't necessarily create a large set of maps, nor do you necessarily point only to existing solutions, but you try to see how can we bring all together, and to do that as a iterative process where everyone is on board. I think that has worked quite well. Of course, there is the question of access of data storage and so on, and that's also something to discuss. But trying to make sure that it's a joint process usually helps at getting out an interesting information product that really leverages space technologies.
Thank you so much, Juan Carlos and Radu. Time is up. It's 3:30, and we're going to close the webinar now. Juan Carlos and Radu, thank you so much for presenting here. No more questions were there, but if you wish to contact Juan Carlos and Radu, you can find their email addresses in the calendar invite. We also invite you to visit the UN Spider website. This event has been recorded, so we will send a summary email around with the recording and of course the link. So please do visit the UN Spider website. More on GIS is coming. We're busy talking with the other innovation challenges on GIS in order to have like a small, short and sexy webinar series, maybe 45 minutes to talk about how to use GIS and M&E, how to bring all these data sets to your fingertips, and how to use GIS and land tenure. So we've got lots of ideas and we're looking forward to sharing this with you. So once again, Juan Carlos and Radu, thank you so much, and have a good day to everyone. Bye.
Thank you. Thanks a lot for having us.
Yeah,
Thank you. Bye-bye.
Thank you. Bye.